Drive.
A systems engineer is kind of like the glue for the project. My name is Jessica Samuels. We are at the Jet Propulsion Laboratory in Pasadena, California, and I am a systems engineer on the Mars Science Laboratory mission. The Mars Science Laboratory mission is a rover that we're sending to Mars. It will launch in November of 2011 and arrive around August of 2012. It is JPL's next rover, following on to the Spirit and Opportunity rovers. Spirit and Opportunity were sent to Mars to figure out, was there any sign of water? That was the Looking for the Water mission. And it was great. We discovered that there was evidence of standing liquid water at one time on the surface of Mars. So our mission is the follow-on mission to understand what sort of processes happened over the time, and is there any evidence that past life may have existed on the surface given those environments that we've learned about from Spirit and Opportunity. So systems engineers come in the early stages, and we start looking at, well, what is the design of the mission? What does the mission need to do? We say, all right, how far do we want this rover to go? We actually put down sentences that say that the rover must be able to travel, 5 kilometers, or the rover must be able to take, 10 different rock samples. As the design of the rover is evolving, we start working with the different subsystems to make sure that all of the pieces come together. The part over here can appropriately talk to, the part over there. After we've built the vehicle or the spacecraft, then the system engineering team is usually involved in the test activities. So now we are thinking of what are the right tests that we need to perform. We're going to drive the rover to a target, and we're going to test that process of being able to drive over, to deploy the robotic arm. We're going back to those initial requirements, those initial sentences that we wrote, and we're making sure that each one is checked off. And so we call that verification and validation of the system. Does the whole system do what we intended it to do? Now the spacecraft is ready to go. It gets sent to Florida. It's launched. And then now the systems team continues to think about, well, how are we going to operate it once it's on the surface? So a system engineer usually gets to see the whole life of the mission, which is pretty exciting. Like previous rovers, we'll actually sleep at night and we'll charge our batteries. And then we have the amount of energy to do all the activities that we need during the day. But we have to be careful because we only have so much power. So you can't decide to, drive 150 meters and take out the robotic arm and start drilling that rock. And, oh, by the way, you're, doing images at the same time. You have a limited set of power, so you need to do some calculations to figure out how much power is each activity going to take. And then we balance that across how much we have available. So every day we essentially have our own little math problem with what's the list of activities we want to do, we calculate how much that's going to take, and then we factor that into the daily plan. I think the biggest challenge is that we're doing things that people have never done before, and we have to come up with new and creative ideas of how to solve problems that sometimes you can't just go Google the answer. Engineering is how things work. It's how to create something. It's how to build something and get a result out of it. It's taking any type of problem and using math to solve that problem. The best thing about my job is getting to say that I work on a spacecraft that goes to explore a different planet. Helping to discover what else is going on in our universe. That's pretty amazing.